Okay, great times. Let us all look at this question 4. There you are given parabola and hyperbola. Your parabola is f of x equals to 2 over 3x squared plus q. Your hyperbola is g of x equals to k over x plus b. A and b are points of intersection of the two graphs. Now, when you look at A, that's where the hyperbola and parabola intersect. That's where your graphs are equal. Then we have the y asymptote, which is 1. Now, look at question 4.3.1. They want to know for which values of x. 4.3, for which values of x is 4.3.1 is g of x less than 1. Now, when we talk about g of x, we are talking about the hyperbola. Where do you find the hyperbola to be less than 1? Then for which values of x? And then 4.3.2, where do you find the hyperbola, your g of x, to be equals to 0? Which means you must look for the x-intercept of your hyperbola. And then you have 4.3.3 where they are saying your parabola multiply by the x-intercept to be less than 0. So a product will less than 0 means negative. A product will be negative when if one term is positive, the other one is should be negative, or if the other one is negative, the other one should be positive. Now let us look at this question and start to answer it. Looking at our diagram there, I'm going to look at the hyperbola for 4.3.1. Let me just get a pen. Okay, let me just draw hyperbola without the parabola just to look at how the graph will look like. 4.3.1. I'm just going to take out hyperbola. Let me just make this pen a bit thicker. Okay, fine. When you look at your hyperbola there, this is your graph. You having your horizontal asymptote, which is y equals to 1. Then you have your hyperbola. That's your hyperbola. And then this is your hyperbola. Now, if you look at this graph, we want to know where is the hyperbola less than 1. Where do you see this graph to be less than 1? Now, one will say, if you look at, let me use a color so that you can see where the hyperbola is less than 1. You can clearly see here from minus infinity, between minus infinity and 0, the hyperbola is less than 1. So 4.3.1, your hyperbola is less than 1 when x is an element of minus infinity to 0. So between minus infinity and 0, the graph is less than 1. But you can clearly see immediately after 0, your graph will be above 1. So that is 4.3.1. Then the next one is 4.3.2. Now, what do they want there in 4.3.2? Okay, this one, or I can still write it using the inequalities to say when x is greater than minus infinity, but less than 0, between minus infinity and 0, the hyperbola, it's below 1. Now, let's see 4.3.2. What do they want there? 4.3.2. Then now they want to know where the hyperbola is equals to 0. That is your x-intercept. So let us find the x-intercept of this hyperbola. To find the x-intercept, what one will do there now, to find the x-intercept, remember your g of x equals to k over x, k over x plus b. Now you must know that this b, that is your horizontal asymptote. If this is the function, g of x equals to k over x plus b. This b, that is your horizontal asymptote, which is 1. So it will be k over x plus 1. Now what I want to do now, looking at the hyperbola, take any point on the hyperbola, there is point A. What are the coordinates of A? -2, -1. There is another point on the hyperbola, which is B, with coordinates -1 and -3. So I can substitute any point as my x and y. Let me take point A. If I use point A, my y value there is your g of x, which is your y value, is -1. What is your x value at that point A? Your x value there is -2 plus 1. Now, if I take this k over -2 to the, remember this is -2. If I take this term to the left-hand side, it will be k. That minus will be positive. And if I take this -1 to this side, it will join that +1, then it will be 1 plus 1, which is 2. Now, we have k over 2. Then what I can do, k over 2 equals to 2. I can then multiply by 2 both sides. Multiplying by 2 both sides, k will cancel with k. I mean, 2 will cancel with 2, not k. 2 will cancel out with 2 there. Therefore, k equals to 2 times 2. What is 2 times 2 there? You will then end up with 4. Then you can clearly see if you come back here and replace back k, your hyperbola is g of x equals to 4 over x plus 1. Remember what we want? We want to find where g of x equals to 0. That is your y-intercept. So my mistake, not the y-intercept, that is our x-intercept of the hyperbola. So we will then say our x-intercept, your y should be 0, which is that g of x. Replace it with 0. 0 equals to 4 over x plus 1. Therefore, if I transpose again this term to this side, -4 over x equals to 1. Multiplying both sides now by x. What will I get if I multiply by x both sides? X cancel out with x here. Therefore, we found now, okay, our x to be equals to -4. So what was the question? Let's go back to our question. Remember, you were supposed to find the value of x when g of x is equals to 0. Now, when g of x is equals to 0, what is our x value? Going back to our question, one can clearly see now that when g of x is 0, x equals to -4. If I were to write this in coordinate form, I have coordinate point -4, 0. So which is this point here, going back to the graph, which is this point here, which is this point here. That's our x-intercept of the hyperbola. When the function is 0, when g of x is 0, your x becomes -4. Then we can look at the next question. Looking at the next question there now, you are given question 4.3.3. They are saying here, for which values of x is f of x times x less than 0? Now, when you look at your parabola, we want to establish where, when the parabola is positive, then we must have a negative x-intercept. Or when the parabola is negative, then we must have a positive x-intercept. Because for a product to be less than 0, it means, let me just write it down, 4.3.3. If you have f of x times times x, and we want it to be less than 0, it means if this f of x is positive, then x must be negative. If the function is negative, then we must look where our x values are positive. Now what I'm going to do here, I'm going to sketch a graph, the parabola graph, and look where the graph, when the graph is positive, then the x-intercept should be negative. Now, let's go back to our function. Question 4.3.3. 4.3.3. Now, first of all, let me look at the parabola. Function of the parabola is given by what? Let's go back to our parabola. It's f of x equals to 2 over 3 x squared plus q. F of x equals to, our parabola is given by f of x equals to 2 over 3 x squared plus q. So we need to find the q value. We need to, if this is the parabola, we want to find this value. That is our q. Obviously, it should be negative. It is on the negative side of y. Positive y, negative y, x, negative x. So we want to find this q value. So we can take any point on the parabola. We know there is a point somewhere here, which is our a with coordinates -2, then -1. Another one is somewhere here. This was your a. This one has coordinate -1, -3, which is your b. So I can take any point and substitute it as my x and y here. Remember your f of x, that is your y here, which is -1. I'm going to use point A. At A, y is -1. Then you have 2 over 3. Your x, it's -2 there. All squared plus q. So if you work out this one, -1 equals to 2 over 3. You square -2, you get 4 plus q. Therefore, -1 equals to 2 times 4 will give me 8 over 3 plus q. 8 over 3 plus q. Bring this 8 over 3 to the left-hand side. We have -1 minus 8 over 3 equals to q. Then if you work out these two fractions, you will end up with minus 11 over 3, which will be our q. Then you can go back to your f of x, replace your q here. What is the q value? Q value is minus 11 over 3. Therefore, f of x will then be equals to 2 over 3 x squared minus 11 over 3. Now remember, according to this question here, now I have found my parabola, the function of the parabola. Now, according to the question, they want, let's look at the question. They want to know when f of x is positive, x must be negative. Or when the function is negative, the x must be positive. Let's go back to our function. Now remember, the graph is going to be, let me just use colors here. The graph is going to be positive when it is above the x-axis, and is going to be negative when it is below the x-axis. Now, allow me just to get a pen here. Let me get a different color. It's fine. Now, remember, if we look at our graph, here our graph is positive, 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 positive. Even here it's positive, 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 positive. Down here it's negative, 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 negative. Now, I want here your graph. It's your f of x here. It's positive, but your x values are negative. So that region, that part, you can see it at that part, the function is positive and the x-intercept is negative. So it is this area here. Let me get the different color again. This area. That's the area. So in that area, the x values are negative, but the function is positive. So let me find the x-intercept here. I need to know what is the x-intercept of the parabola. Let us find the x-intercepts of the parabola. Fine. To find the x-intercept, y should be equals to 0, which is our function there. 0 equals to 2 over 3 x squared minus 11 over 3. Okay, get rid of the lowest common multiple. So what will I do to get rid of the LCM? I will just multiply by 3. Multiply each term here by 3. Multiply by 3. So 3 times 0 is 0. These 3 cancel out with 3. Then we have 2x squared. 3 cancel out with 3 here. Then we have minus 11. Therefore, we can clearly see that our 2x squared will then be 0 equals to 2x squared minus 11. Then if we take this to this side, minus 2x squared equals to 11 minus 11 over 2. Then what one can do now, okay, what have I done now? I have divided by negative 2 both sides. Therefore, x squared equals to 11 over 2. Taking the square root both sides, x equals to plus or minus, square root of 11 over 2. So we can use a calculator to find what is the square root of 11 over 2. So now we can clearly see if we go back to our graph, our x values we found. So obviously this is minus, this one will be minus, it is on the negative side, minus square root of 11 over 2, square root of 11. And this one here, it will be on the positive side, which is the square root of 11 over 2. Now let's see, where do you see this graph to be positive? The function is positive here. From minus that square root of 11 over 2 going to the left hand side, and the x values there are negative. So one will say for that 4.3.3, the solution will be x should be an element of from minus infinity. I don't have a calculator, I will just write this as a set number, minus, from minus infinity to minus square root 11 over 2. That's where our product is going to be negative, because from there you can see the function there, f of x is positive and the x values are negative. Positive times negative is negative, which means less than 0. Our product becomes negative. Anything that is negative means it's less than 0. Now let's look at the next one. Where else do you find the solution? If you look here, these x values are positive, but the graph is below the x-axis. The graph is negative, but the x values are positive. So it will be, remember this is 0. So the another solution will be x element of 0 to positive square root 11. Okay. To that square root 11 over 2. So that will be your solution. From minus infinity to negative square root 11 over 2, that's where the product is negative. Another solution is between 0 and square root of 11 over 2. So that's how this one will be answered. Question 4. Okay. I hope, guys, we are together. Please don't forget to subscribe. We will get more functions.